So the agenda, I will talk about 10 different techniques on macOS which can help you persist if you are a malware or red teamer or pen tester or whatever. So how many macOS users we have here? Some. So how is all started? Back in 2014, Patrick Wardle gave a talk and wrote a white paper about malware persistence on macOS, and he explored the most common options malware used for persisting. And there is this guy called Adam from the UK, goes by the handle Hexacorn on Twitter, and he has a series for Windows called the Beyond the Good Old Run Keys. And he has documented like over 100 persistent tricks for Windows. And I also found, so I don't usually deal with macOS malware, but I kind of used to at least read the write-up or the research going around them. And I realized that actually 99% of them uses still like LaunchAgents. And probably because it just works. And I started to wonder, okay, can we do better, or are there any other options beyond what's already documented? Because I'm pretty sure that eventually it will show up. So the macOS or the MacBooks as a platform, it's becoming more and more widespread. Actually, I was surprised that in the US now it takes like 15% market shares, versus a couple of years ago it was like 8%. So as it will be more widespread, malware authors will turn more and more for Macs, although we all know that there are no viruses for Mac. So I also started a series called Beyond the Good Old LaunchAgents. Why LaunchAgents? It's like the run key on Windows, so that's the most common way to persist. So I started this blog post now. I have like 29 parts to it, and I selected my 10 favorite out of them, but there are many more than just these I will present. So my first favorite is the shell startup files. So this is a common, this can be a common persistence for not just macOS, but basically any Linux-based system, Linux, Unix, anything that has ZSH, Bash, and all these shell environments. On macOS, ZSH is the default, although it still has the older ones as well. So all these shell environments have various config files, like probably ZSH RC is the most common one. It sits in the user's directory, and you could define their aliases, some startup scripts, whatever you need for your shell environment. Bash has the same, Bash RC, and there are like ZSHN, zlogin, zlogout. Like zlogin is executed when you log in, zlogout is executed when you log out. There is the .profile for, I believe, SH. And usually all of them has a user mode settings in your user home folder, and then there is a system-wide one, which on macOS sits under the /etc directory. So basically, if you put any bash script in these files, it will be run whenever a shell environment is started. Now, macOS doesn't start a shell environment by default, but whenever you open terminal, it will start a shell environment, and all of these will be executed. Now, beyond that, why this can be interesting. macOS has this concept of privacy protection, which is called the TCC framework. And so these are all the prompts when you get that, hey, this application wants to access your camera. This application wants to access your microphone. This application wants to access your desktop folder. This application wants to access your documents folder. This application wants to do, I don't know, capture keystroke, do screen recording. And actually, even if the application runs as the normal user, he cannot access these resources because Apple considers them as private. So you need to actually give each application permission for each write. And now there is this write called full disk access, which is required for many things on macOS, and it's more and more required. So I think power users or like developers or IT people will typically give terminal full disk access. Now, the problem with this is if you persist through shell startup files, terminal will start the shell, and that shell will inherit terminal's privacy rights. So if terminal had like full disk access, your shell script will inherit that, and you will also get full disk access. So, but just to show what I talk about, if you haven't seen this, so let's say like the messages, the iMessages is a protected location. So if I try to list that, I got operation not permitted. Now the only way I can actually get access to this location is give full disk access to terminal. No, I don't need to restart it. And now I can list it. Now if I revoke the access, no, don't restart, it's again operation not permitted. So this is a privacy protection feature. So if I highly recommend, if you're a Mac user, don't give anything full disk access unless it's really needed. Like there are some applications like anything that implements or uses the endpoint security framework, for example, they have to have full disk access in order to function. Anyhow, so how we can detect these as blue teamers? So just monitor for change any of these files. I think if it's there might be some false positive, especially with power users, but generally average users probably don't modify these files. Also monitor for the execution of chsh, which is a command to change the shell environment. So you can change the default shell from ZSH to bash, for example, on macOS with this command. Also monitor for chpass execution, because that can also change many attributes concerning the shell. And I believe these might apply to us on other Nix-based system. So the next one is the pluggable authentication modules, the PAM. This is also something that you will find not just on macOS, but on other Nix-based systems. It has its origins from Red Hat, but nowadays I believe most systems will implement it. Basically what it does, it allows you to install third-party plugins to perform various authentication-related operations. So there are 4 facilities defined in PAM. One is auth, account, session, and password. And these are related to authentication, account management, session management, and password management. And all the configurations files for PAM can be found under the /etc pamd directory. So how such a configuration file looks like? It has 3 columns. The first one defines the facility, like what we just described, the auth, account, password, session. The next column defines the policy, and the last is the actual module that will implement that functionality. Now, the second column is interesting because it will define if how the result of that module is treated. So if it's these are executed in top-down order. So, and if there is a required, if it fails, then the entire operation or the entire result will fail. So like there is a required module to pass authentication, and if that fails, then authentication will fail. Optional, it will be ignored if there is a required one, but sufficient, if it succeeds, then there will be no further checks. So if we like put a new entry at the very top and say, okay, it's sufficient and it will succeed, then nothing else will be checked. There are two interesting default PEM modules. One is the PEM permit.so. It will just return success for everything without any checks. And there is the PEM deny.so, which will just deny everything. They are built in. So what we can do, for example, is create a new entry and say, let's say for SSH, and say out, like authentication, sufficient, PEM permit, which means that whenever you try to SSH into a Mac, it will succeed and not prompt you for a password. So this is actually also a nice backdoor. You can do the same for sudo. Just say, OK, out, sufficient, PEM permit, and every time you type sudo, you will not be prompted for password. You just get roots straight away. Now, because PEM is extendable, we can also load our own plugin and do really whatever we want. This code here is just like an empty template. Probably looks like PEM permit. It will just return success for everything. But you can add your own logic and do whatever you want on your own malware, red team, implant, whatever. So the reason we can load plugins in the PEM framework on macOS is because all of the services have this entitlement, COM Apple Private Security Clear Library Validation, which is required to load anything third-party. By default on macOS, you cannot load a third-party dylib. Dylib is the DLL on macOS into a platform application because process injection is a thing on macOS because all of the processes has entitlements, like various entitlements, which gives the processes various rights. For example, privacy rights that like FaceTime has a right to access the camera without any prompt. And so if you can inject into that process, you gain access to the entitlement. And this is why like generally process injection is a big no on macOS. So how we can detect this persistence? Now, first of all, the good thing nowadays is the privacy framework will protect the PEM configurations files. So if you try to modify these, the user will actually get a prompt that, hey, you need to give this application system administration rights. And if he clicks deny, then it will not succeed. Although probably on macOS we have this prompt fatigue, so like there is an insane amount of prompt the user get on macOS, so they might just click, yeah, sure, go. So monitor the change. Monitor for the change of these files, all the config files, and also if you have something like appmon, or I think the elk agent can also collect various events from a Mac if you use an enterprise environment. There is this ES event type out mmap event coming from the endpoint security framework, which basically tells you what kind of module dylib was loaded into a process. So you might want to monitor for weird dylibs loaded into the SSH sudo or the other services, because if you didn't install any third-party module and you know that you didn't install one, now suddenly one showing up might be interesting. The third one as a persistent is Hammerspoon. This is an automation application. So this is not something core to macOS, but this is more like an application-specific persistence. But if someone has Hammerspoon installed, Hammerspoon has an initialization script located in the home folder, the .hammerspoon/init.lua. It's a Lua script, which I personally don't like that much. But basically, you can just do hs.execute and then give the bash script, and then you can execute some bash script easily, and you don't need to deal with the more Lua nuances, although there are more examples on the application website. Also, Hammerspoon has a lot of entitlements to ask for access for various privacy-related stuff like camera, calendars, address book, photos library, and assuming the user already granted access, then if Hammerspoon will execute your script, you get these accesses as well. So it's like a TCP bypass at the same time. Detection, again, it's very simple. Well, first of all, monitor for the change of this file, and also some weird child processes of Hammerspoon. So all this detection I talk about, this is probably more relevant in enterprise environment when you log what's happening on your Mac devices. So the first one is preference panes. What are preference panes? On macOS, we have this system preferences application, which is there to configure many settings on macOS. And basically, you can add new plugins to this. I added one below, persistent worm. It has an Apple logo with a worm. Basically, what you do is create a new bundle, a pref pane bundle, and place it inside the library preference panes directory. And on the next time system preference is executed, it will load your bundle, and you will show up there. Basically, you can just create a bundle and add this single function, and whenever it's loaded, your code will be executed, and that's all. So it's quite simple. But where is your code loaded? Because it won't be system preferences that loads your actual plugin, but it will be a process called legacy loader, and that will load your bundle. This one also have the disable library validation entitlement, so it can load it, and nothing else, so you don't get access to other fancy entitlements. If you were, then that would be a vulnerability on macOS. Again, detection, monitor for any new files in the preference panes directory, and any modules loaded by the legacy loader process. Because if you don't use in your environment any applications that have a custom preference pane, then this process shouldn't load anything really. Next one, Screensaver. This was first very well researched by Leo Pitt Doomfist on Twitter, and he has a very detailed blog post about it. Basically, the screensavers are also bundles on macOS. So let me step back. Bundle on macOS is basically an application, or it's basically a directory structure with some defined content. So bundle contains the main executable or the resource file the application need, configuration settings, and maybe other frameworks, other dylibs. So basically all of the applications are bundled into a single directory structure which contains everything the application needs. But there are other bundles with very similar structure, not just applications. And for example, Screensaver is a .saver bundle, so the directory has the .saver extension. These are also saved in the library Screensaver directory. And it's very easy to create one because Xcode, the developer environment for macOS, has a template project. So you can just start it, put your code in every function listed there, and there you go. It's pretty straightforward. Now, the screensaver will be loaded by another process called the legacy screensaver process. And unfortunately, the bad thing with this is that it's sandboxed, which means that you are restricted what you can do. And actually, this process is so sandboxed that it doesn't really have too many rights. So it's quite locked down. So if you want to use this as a persistence, you need to have some sort of sandbox escape to know how to get rid of the sandbox. Detection, again, new files where the screensaver should be placed, files loaded by the legacy screensaver process, or if you just find out that a new saver bundle is showing up on the system, that could be also a nice indication. So maybe the user downloaded a new screensaver from some questionable website, and it will show up in the downloads folder, and maybe before the user puts it in the right location or installs it, maybe you can take action and block it right away. The next one is color pickers. This was surprising to me because I didn't know that on macOS you can make a custom color picker. So what is a color picker? Basically this pane you see there, where you can pick a color for your font, for your background, or for whatever. These called color pickers, and turns out each of these tabs on the top is a different color picker, and you can implement your own on macOS. This is something really old stuff, or not that well known, but I still found a couple of sample projects on GitHub from like 8-9 years ago. People showing, okay, this is the way you can implement a color picker on macOS. I wonder really how many ancient plugins macOS still supports like this. It would be interesting to explore all of these. There are some obvious locations called the plugins, but this one is not obvious. Like the library color pickers directory doesn't even exist by default. So if you want to install your color picker, you have to create this directory. So it's not obvious to find all of this. But yeah, it will be loaded by the legacy external color picker service process, and unfortunately it's also sandboxed. But I still found it interesting because I think it's not a well-known, not just persistence, but a feature at all on macOS. Again, detection is just the same as all the others, so any new files in the color pickers directory or files loaded by this legacy external color picker service or any new color picker bundle. Periodic scripts. This is probably my first top favorite is the PAM modules. Really, this is the second because I keep abusing this feature in exploitation, not for persistence. But what it is, periodic scripts are maintenance scripts. It's coming from FreeBSD. So actually macOS has some FreeBSD origin, and it inherited all of this stuff. And there are 3 types of scripts. They are run either daily, weekly, or monthly. And all of them have their own launch daemon file, which we can see the com apple periodic, daily, monthly, weekly, plist. Since they are launch daemon, it means that they will be run as root. And now what happens here is all these launch daemons will call the periodic wrapper process, which will launch the USR has been periodic bash script. The script themselves are located under the etc/periodic directory, and there is one for daily, weekly, monthly script. There are a bunch of them, and basically what the periodic bash script does is enumerates all the scripts, goes through and executes all of them. These are bash scripts. And there is also a config file for periodic, the periodic.conf, and it has defined the secondary place, the USR local etc periodic, where you can place your own periodic scripts if you want. Now, actually, you can place your own scripts in the main directory as well. It's not protected or anything, but you can use the other local directory. Now, the interesting thing with this location was that if you have Homebrew installed on macOS, Homebrew is a package manager for macOS. Homebrew sets the USR local directory to be owned by the local admin user or the first admin user on the Mac. Now, typically a Mac has a single admin user and that's it. Because by default it's owned by root, but it changes it to the admin user. Now, on macOS, going from admin to root is considered a security boundary, versus on Windows it's not. Because on macOS you actually need to authenticate to go from admin to root. With typing your password or your fingerprint or something, but you have to do an authentication. So it's a boundary. But because the USR local directory was set to be owned by the user, you could create this etc periodic directory, place a script there as a user, and that script would be executed as root. So it's like a trivial privilege escalation. And Apple fixed this in Big Sur 11.5. And what they did, here's the diff of the periodic scripts. They check the owner of the maintenance script, and they will execute the script with the owner of the script. So if you created the script as an admin user, it will execute the script as the admin user and not as root. So they were nice to close this, although this was really not a macOS problem. This problem was because you installed Homebrew, which changed the default settings. Now, but interestingly, you can, if you do exploitation on macOS and you find a way to drop a script somewhere which is owned by the user, I commonly use the periodic script to drop a file in the periodic location and get it executed by the periodic wrapper in a day to achieve some privilege escalation. But now it's gone, because if I drop a file there as the user, it will be executed as the user and not as root. But if we can still do that, so the 999.local script defines more locations, and what it will do, it will execute the scripts we can see there, like the daily local, which is the /etc/daily.local, and there is one for weekly and monthly local. These files don't exist by default, but if we manage to create them, the 999.local, which we run as root, will execute these as well. Yeah, detection. I think there are a couple of things here. First of all, monitor for the change of the periodic config file. That shouldn't change really, because someone can define a new location for the scripts. Basically monitor for the change of any of the scripts or any of the folder containing the scripts, and probably also monitor for some weird processes started by periodic. So normally applications don't install periodic scripts, so you can make a baseline what it's executed in normally, and then anything that doesn't fall into that bucket is an outlier and probably a malware or red teamer or something else. Next one is terminal preferences. So this is terminal for those who don't have a Mac. And terminal can define a startup command under the profile. And basically, this is what we see here at the bottom. You can define a command, which is a bash or a shell command, and that will be executed when terminal is launched or first started. This configuration is stored in terminal's preferences file, which is in the library preferences directory. It's a plist. Plist is a property list on macOS. Basically, it's a configuration file. It can be either displayed or stored as a binary format or in XML format. I believe nowadays they try to default to binary format, but you can still print it as an XML or overwrite it as an XML and it will work. And basically, your command will be stored under the Windows settings, basic, and command string. So you can just inject this into the plist without touching terminal at all. And next time terminal is launched, you get your code executed. Detection, just check for the modification of this file. Now, if someone changes the preferences in terminal, like they enlarge the font or change the colors or whatever, this file will be changed. And so you might get plenty of false positive. Now, the other thing is that preferences is not changed by the terminal process itself, but there is a daemon on macOS called the cfprevsd, which runs as the user, and there is another instance that runs as root. And whenever you want to change a preference, you call the preference API, and that API will call out to the preference daemon, and the preference daemon will be the one that saves or loads the settings. So basically, this preference file is always modified by the preference daemon, normally. But if maybe another process directly touches this file, that's not good, for sure. Although your custom binary can also call the preferences API and modify it through the preferences daemon, so there are ways around it. But yeah. The ninth one, it's the emon, the event monitor daemon. It's also some very old process or daemon for macOS. There have been two previous work on this, one by James Reynolds and Chris Cross. Both of them wrote a very detailed blog post how this daemon works, what it can do, etc. It's quite complex to set it up, and I don't think that anyone really uses this nowadays, but it's still there. So first of all, this service is not started by default on the system. To start it, you have to place a file in the private var db emon clients folder. Any file. Just drop a file, do a touch, and once something is there, the process will start up. So this is the first step. Then there are rules for this daemon in the etc emon.dd/rules directory, and it also has a config file which contains the additional rules path, so it defines a location where you can also set up rules. So here is a sample rule. Basically, the rules define what this daemon should do and on what event should react or do anything, basically. So here's a sample rule. It monitors, or it's for the event type startup. So whenever the daemon starts up, this rule will be triggered. Then we define the action, and under the action we define command, which would be bash in this case. Then we define the user we want this command to be run under. We set it to root, and then we set the arguments for the command. And basically here we just run a simple bash script. And then there is also the type, which is run command. So this is the way, this is a rule file or the way you can execute a bash script with the daemon D process. So detection, first of all, any new, if daemon D is usually not used in your environment, any new file in the daemon clients directory is a huge alert because there shouldn't be really anything. Then any new or modified files in the rules directory, change of the daemon plist configuration file, and any child processes of daemon D. I think any of these can be a huge red flag normally. And yeah. So the last one is called folder actions. It was first detailed by Cody Thomas in his blog post. And folder actions are scripts that run when files are modified or added or deleted from a certain folder. We can define folder actions in Finder. And all these scripts are located in the library scripts folder action scripts location. Now, it's not that simple that we just place our script there and it will be executed. There is a configuration goes with that in the folder action dispatcher plist, where we need to define the folders we want to monitor and the actions we want to take, like which script to execute. Now, this is a very ugly plist because it has a very weird setup format, and then it contains an embedded plist in base64 format, and that embedded plist contains another embedded plist, which will actually contain the final settings, and the entire configuration is weird with some weird names, and I didn't start to reverse it. Okay, how you do it? What you can do is create a new folder action through the GUI, save it, and it will create the plist for you. Now, you can just take this plist from your computer and drop it on any other Mac, and that will work. So, how we can set this up without any user interaction, because that's not straightforward. So first of all, we create the directory for the scripts because it doesn't exist by default. We copy our script to this location. And then let's say we defined the test directory, which we want to monitor or take action on, and save the settings for that. So we create the test directory, and then we copy our prepared configuration file into the preferences directory. We are still not done because it will not go into effect right away. What we need to do is open the folder action setup application, and then we can kill it as well. But basically, whenever the folder action setup is executed, it will make the whole thing live from that point on. And then if we reboot the computer, it will stay active. But for the very first time, we need to do this. Now, what's interesting is the script that we drop there will be executed by the folder action dispatcher process. And if we want to access any privacy-related location, obviously it doesn't have the right, but it will prompt the user for that. And what the user will see in this case, that the folder action dispatcher process would like to access something. So it's not your script or whatever file that the user will see that file or that script wants to access something, but it's the default folder action dispatcher process. Now, first, I doubt that most people will know that this exists or know what it is, but it can be still misleading. Because what they see, okay, this is like a legit process comes by default with the system, so it might be right. It's not harmful. It's installed by default on the system. Detection. So there are few steps to this. First, any new files, scripts in the for direction scripts folder. Then the change of the configuration file. And then the process which is responsible for launching the scripts is the Apple Foundation user script service process. So you can also monitor for this process launching any other processes or scripts or whatever. So there are a few options here. Conclusion. So malware actually still uses LaunchDP list. Probably that's because it works. Unfortunately, some of these persistent techniques, while interesting, some of them requires you to have root, some of them sandbox, so not all of them are perfect. Some of them are application specific. So they are not perfect, but they might work. Some of them relies on the user executing an application like terminal or Hammerspoon. Some of them will work just nicely. But I think there are many unexplored options. And I think we need to prepare for this as defenders. And if we are red teamers, we can just add all of these to our arsenal and try to use them. And I have many others on my blog post, like right now I think 29. And before I go to the questions, I want to recommend a tool which is written by Patrick Wardle. It's called BlogBlock. So if you have a Mac, I think this is like a must-have tool. This is free. What it does, it monitors for many locations which contains through which you can persist. And the LaunchAgent is one of the examples. And it will alert you. So let me just show this. Let me just create a file in here. And I got an alert that, hey, the touch application is installed a new LaunchAgent. Do you want to allow it or not? And I think this is pretty cool. And LaunchAgents is not the only directory this tool will monitor. So I think if you have a Mac, have this tool, especially that most malwares, they use LaunchAgents. Basically, this tool can block almost all of malware nowadays on Mac. So yeah, it's free, cool, easy. So yeah, use it. Any questions?
Anyone? Yeah, go.
It depends. So the question was if sandbox processes cannot touch the system, but can they open like network connections and so on? I don't remember. It's the way it's defined. The sandbox process should have an entitlement for like allow network connection, allow, I don't know, access this resource, and I don't remember if these processes has that. So it might be able to open a network connection, or it might not. I'm not 100% sure. Actually, if you want, we can. It takes just a second to see that. I have the process here, so let's see what it can do. So this is app sandboxed. What it can do, so it's a network client, so it can open network connection. And it can access like bookmarks, user-selected files, and a few other stuff. It's limited, but yeah, it can do a few items.
Any other questions? Come on, don't be shy.
Yeah, I'm also from Hungary, so we also
Go ahead, sir.
don't like. No, so I don't do.
So we should repeat the question maybe.
So what's my experience with people clicking OK or just move on with all these prompts? I don't do red teaming for macOS in any environment, so I just do all of my research in my own PC. But my guess is that probably on macOS, people click allow. Like all this. So all this stuff we see here, so these are settings for all sorts of privacy stuff. Like it's a list of, I don't know, like 20 items. And each application has to prompt for each item. Now, probably over time it's less prompts, but when you initially start to use a device, you get a whole lot of prompts. And I think users will be just tired of this and hello. And yeah, they want to go on. So my guess, and this is my personal opinion, is that people might actually click, okay, hello.
Any other questions? No? Are you guys sure? Okay. Then I guess a round of applause for Czaba's excellent talk.
Thank you.